So we're going to look at this warm-up from our previous lessons, and we're even going to look back at our properties. So, write an expression for the phrase 5 less than 1/3 of George's age. So, Daniel came up to me, and he had written down 5 minus 1/3 times G. Looks great, right? What do we think? What do we notice, Hannah?
That if you were doing 5 minus 1/3, it would imply that you're subtracting 1/3 from 5.
Well, that is a good idea. He has the times there to make it times, but there is a problem with where he put something, Lucy.
The problem says 5 less than, so you know that
Exactly. So it would have to be minus 5 because it comes after. Then we see this word of. What does of mean in math, Hannah?
Multiplication.
Means multiplication. So then we've got 1/3 of. And do we know George's age? No. So this is our unknown. We make it a variable. So the answer is going to be 1/3 times G minus 5. You could also write it as 1/3 G minus 5. Or if you really want to be inconvenient, you could write it as G over 3 minus 5. Now, Ben asked a great question. He said, can we do G minus 5 times 1/3? Did I write it the way you want it?
No.
How?
1/3 at the end.
So like times 1/3 like that? So we can't write it like that because according to PEMDAS, we have to do this part first.
Yeah, but then you wrote parentheses.
So parentheses around what?
The G and the 5.
So the G and the 5, regardless, that's still G minus 5 times 1/3. We need 1/3 of his age, then take away 5. So the only expression that works here would be 1/3 G minus 5. Now that we have that expression, I want you to solve it on the paper. If G is equal to 27, so if George is 27 years old, I want you to solve what the answer we will get is. Show me on your fingers. What is the answer? What's the answer? The answer is 4. We plug in 27. 1/3 of 27. 27 over 1 times 1 over 3, or 27 divided by 3 is 9. 9 minus 5 is equal to, 9 minus 5 is equal to 4. Excellent. So, I want one more question from you. We're going to use hand signs to answer this. So, this is an expression. The expression says x minus 3 is equal to y minus 3. And you're going to tell me, is that the case always? Is that the case sometimes? Or is that the case never? So I want you to think about it, and then I'm going to ask you to raise your hands in association. Let's look at, we're going to do our hand signals. If you think it's always, show me paper. If you think it's sometimes, show me scissors. And if you think it's never, show me rock. So the answer is sometimes. Yeah. So let's look at this case. First case that I can do is I can eliminate always. I can eliminate always because I have x is equal to 3 and y equals 4. If I do those numbers, are they going to be equal? No. So I can eliminate always. Then, let's make them have the same number. That's totally legal. Think about it like twins. They've got the same age. They got the same birthday. Totally legal. If they are both 3s, if they both have the same number, are they the same? Yeah, they're the same. But does that mean that so we get rid of that never, because here's an example where they're the same. So only sometimes can different variables with the same equation mean the same thing. So we're going to be starting lesson 6.7, working on equivalent expressions today. 6.7 equivalent expressions. So I want you to simplify both of these expressions. The way that you do it, who knows how we simplify expressions? What is it called, Ben?
I don't know what it's called, but I know what
You know the answer? What is it called, Lucy? Yeah, it's called combining like terms. When we combine like terms, what we're doing is we're searching for the terms that look the same, that have all the same things. 2x. Does 2x have a term that looks like it?
Yeah.
What term is it, Ben? 4x. They both have x's. What about -3? Does -3 have a term that looks like it?
I thought it was minus.
It's -3, -3, -3, same thing.
Oh, I thought it was minus 3 plus 6.
It is. It's -3 plus 6 or -3 plus 6.
I thought it was like minus 9.
It. So we go from left to right. Now we look at this.
4x.
-3 plus 6. Those are both numbers, so they are the same. Same with our bottom. These are both numbers, and these both contain the same variable.
7x.
So what I want you to do is simply combine the color coordinated portions. You just combine them and solve. We combine the like terms. When we combine the like terms, what do we get? What do we get when we combine these like terms, Lucy? So we've got -3 plus 6. So if I went on my number line, I know negatives are hard for you guys. Let's go to my negatives. So I go -3, 1, 2, 3. And then I add 6. 1, 2, 3, 4, 5, 6. Where did I end up? If this is my 0. What number is it, Daniel? It's 3. And it's a positive 3 because we went to the right. This is the answer that we would get. 6x plus 3. We combine like terms. Let's look at this one. 7x minus x. What is 7x minus x? This is 1x. What is it, Hannah? It's not x. 7x minus x. Rocco? Not 7xx. Liam? Good guess, but we're not taking away the x. What is it, Daniel? Not 7x. Does anybody? Jenna? It is 6x.
That makes sense. Yeah.
So the reason is we can't eliminate variables because we don't know what they are. But we have it be 7x minus 1x. X on its own just means 1. X on its own just means 1x.
Wait, are you telling me that's -6?
How many smiley faces do I have right there? How many smiley faces do I have, Jaden?
No one in his class.
1. Do I need to write 1 in front of it so we know? No. So here we've got 7x minus x. X is the same as 1x. We don't write that. 7x taking away an x is now 6x. What is -6 plus 9? -6 plus 9, Lucy? 3. Hey, look at that.
How do you know if it's like negative?
Look at that. We are having major cause for contention over something I did not imagine. So, I want you to look at these, and I want you to give me the answer for all of them. Give me the answer for all 3 of these. What's 6 minus 3? It's 3. 6 plus -3. 3. -3 plus 6. 3. I can say -3, or I can say -3. They are the same thing. So I want you guys to copy down the terms. What I care about is literally the word term, coefficient, constant, and like terms. Those are the 4 important words I need you to copy down. You can do it in bullet points. You can do it however you want. These 4 terms you will see for the rest of your life. These 4 terms you will see for the rest of your life. So Ben messed up because he forgot PEMDAS. He correctly did that. He got 6x. But then he decided to add the 3 and the 6, make them 9, and then do the subtraction. What is the error that he made, Rocco?
That's not what you're supposed to do.
Yeah, that's not what you're supposed to do. What are you supposed to do, Liam?
Stop that.
What do? We go in a specific direction. What direction is that?
Left to right.
We always go left to right. So we have to go left. We keep going. So we do the -3 first, and then we add 6. Follow PEMDAS. When you don't follow PEMDAS, you get embarrassed in front of the whole class. That's why. So, Miles, what do we do for that first one? You noticed it.
Yeah, we add the 3x and the 2x because they both have x's.
They both have x. When we add 3x and 2x, do I get 5xx? No, I just get 5x. So what if I was subtracting? If I subtracted 7x minus x, do I just get 7? No, I'd get 6x. So that's how we do this. I have 5x. Can I combine that 9y with anything? So it just stays the same. What about this next one? It's technically already simplified, but let's just multiply it out. When we do the distribution method, we multiply the outside times everything on the inside. What is 7 times 3x? 7 times 3x. What is it, Ben?
10x? I mean, 21x?
21x, exactly. Then we've got the addition sign. And what's 7 times y? Lucy. 7y. So, the next one we want to factor it. We want to make it something with parentheses. What we do is we find our greatest common factor. What's the greatest common factor between 12 and 8, Anita? 4. We can pull out a 4 from each of them. If we pull out a 4 from 12x, what am I left with? If I divide 12x into 4 groups, what am I left with? What is it, Liam? 3x, exactly. 3x. Then I've got the plus sign that I have right here. What if I took a 4 out of 8y? A 4 out of 8y. What am I left with, Lucy? 2y.
Why?
Exactly. So the problem that you guys are having is that we're not getting a numerical answer. We're not supposed to. Do we know what x or y equals?
No.
So we have to leave them as x and y until they tell us what they equal. So we're going to look at a couple more together. Ready? We're going to do these first 3 together. Simplify each expression. I've got 5 times 6x. What is 5 times 6x? What's 5 times 6x, Hannah? 30x. That's it. All I do is I multiply it in. And it applies both to the 6 and to the x. Next one, we combine like terms. I have a 2x and I have a 7x. Then I have a 5y. I like to color code because it makes things easier. That 5y, can I combine it with anything? No, I can't. So I just leave it as 5y. But what can I combine, Adriana?
Can't you do 9x plus 5y?
Yeah, so I combine the 2x and the 7x. We're adding, so I get 9x. My answer is 9x plus y. So I want you guys to work on 3, 4, 5, and 6, okay? On the guided practice, it is page 498. Here's my example of the terms. X is our variable. 3 is a constant. Anything without a variable is a constant. And then when we do have a variable, the number in front of the variable is our coefficient. So let's look at number 4. It says factor 35x plus 28y. What Gloria did is she found the greatest common factor for both of them. She found 7. So she pulled out a 7, had 5x, and then she pulled out a 7 and had 4y.
How do you get 5, 7?
So she is completely correct here. Because if you multiply it back in, what's 7 times 5x, Miles?
Oh, 35x.
35x. What's 7 times 4y? What's 7 times 4y, Adriana? 28y. So we broke it down. But we take it one step further. Are you ready? You see how they both have 7s? You see how they both have 7s? We're essentially able to regroup them into looking like this. They're both 7s, so we're going to put that here. This is a 5x plus 4y. So we just get 5x plus 4y. I want you guys to re-multiply that out. Let's look. 7 times 5x, we get 35x. 7 times 4y, we get 28y.
Oh, distributive property.
It's the distributive property. exactly as Hannah said. So, it's the distributive property exactly as Hannah said. So what we're learning how to do is do, in this case, 3 is the distributive and 4 is reverse distributive. Yes, Liam?
Can you check out number 8 on the homework page?
Yes, I will look at that. So I want you guys to keep doing this, figure these out. If you have questions, come to me. Our homework, by the way. So the homework is page 499, numbers 1 through 12. And if you can, I really, really suggest trying 13 and 14. I really suggest that. So, for number 3, we just multiply them in. 4 times 2x, we get 8x. We have our plus sign. 4 times 5y, we get 20y. For this one, for number 4, when we factor it, we find the greatest common factor. Who can tell me the greatest common factor between 35 and 28? Yes? 7. We're going to pull out a 7. What's 35x divided into 7 groups, Anita? 5x. That x doesn't get divided because we can't get rid of it. Then we have our plus sign. What's 28y divided into 7 groups, Anita? 4y. That's our answer. We're not getting anything different. Next one. Michaela bought 5 skirts at X dollars each. So, we have 5x because it's 5 skirts times X. That's our first sentence. 3 of the 5 skirts came with a matching top for an additional $9 each. So then we have 3 of them costing $9 each. Write and simplify the total cost of her purchase.
If we do this, do we get extra credit?
That's the exact same thing. All we're doing is we're adding. We've got 5 skirts that cost us X dollars. Then we have 3 more that cost an additional $9 to get the top. Let's simplify it. 5x plus 3 times 9. What is 3 times 9? What's 3 times 9, Lucy? We get 27. Can I simplify this anymore? Do they have any greatest common factors? No. That's our answer. Let's look at this one. The gift bag from Claire Cosmetics includes 5 bottles of nail polish and 2 tubes of lip gloss. Use P for each bottle of nail polish and G for the lip gloss. So write an expression that represents the total of 8 gift bags. So we don't know what we have. So the gift bag has 5 nail polishes, correct? So it's got 5 nail polishes. And we have 2 glitter. But we also want to know how much it costs for 8 gift bags. So we're multiplying all of that times 8. When we simplify that, what do I get as my simplification, Anita?
40p.
Exactly. 40p plus 16g. That's it. For this one, find the value of y that makes each equation true. Let's combine our like terms. What 2 terms can I combine in this? What 2 terms can I combine, Gloria?
3x and 6x.
Perfect, 3x and 6x. What do I get when I combine them, Hannah?
9x. Oh.
9x is equal to yx. So how much does y have to equal for them to be the same? If 9x is equal to yx, y has to be what, Rocco? 9. That's it. Because when I make y 9, they match. Let's look at this one. What terms can I combine here? What terms can I combine here, Rocco?
11 and 12. 11x and 12x.
11x. The 12x is on the other side of our equals, but what else? What else, Daniel? 11x and x. When I combine those, what do I get? What do I get, Daniel? I get 12x plus 5 is equal to 12x plus y. What is y going to be to make this equation true? What is it going to be? Hands up. 5. You see how easy these are?
Wait, do you
Yeah.